So pure mathematics paper 1, 2, May, June 2026. So let's start off. Question number 1. Solve the equation given over here. We know you're going to multiply through to clear the fraction. You're going to multiply through by x squared. And you end up having a quadratic equation and x4, which in the end you're going to write it as x squared and then all squared and do some substitution. So I'm going to start the substitution straight ahead from here. We'll let x squared be equal to a variable a, so that the question becomes 3a minus 8 minus 16 over a is equal to 0. Now you multiply through by a to clear the fraction. So here by a, this 8 by a, here by a, and the 0 by a as well. So that we have 3a squared minus 8a, then minus 16 equal to 0. And we have a quadratic equation in a, right? So a times c is 48, and then we have negative 12 and 4. That will give us negative 8. So 3a squared minus 12a, then plus 4a minus 16 is equal to 0. We pair them and then we factorize. So 3a is a common factor to both terms. Then we have a in here minus 4. Then 4 is a common factor in the second bracket. 4a divided by 4 is a, minus 16 divided by 4 is 4, is equal to 0. So we have 3a plus 4 in one bracket, and then a minus 4 in the other bracket equal to 0. Then by the 0 multiplication theorem, 3a plus 4 is equal to 0, or a minus 4 is equal to 0. Over here we solve and we get a is equal to negative 4 over 3, or we get a is equal to positive 4. However, we did the introduction of a, so we need to bring back our x. We said x squared is equal to a. So we replace a by x squared. Going to do that over here. So x squared is equal to, first of all, we do the negative 4 over 3, which means that to find x, we need to take square root of both sides, but then square root of negative 4 over 3 will not give us a real number, but x is a real number. So there is no solution from this value of a, right? Then move on to the other one. X squared is equal to 4. Here we can take square root of both sides, and then square root of 4 is plus or minus 2. So x is equal to positive 2 or negative 2, and that is our final solution. Now for question number 2, in the diagram, the equation y equals f of x is shown with solid lines, and the graph of the equation y equals g of x is shown with broken lines. Describe fully a sequence of transformations which transforms the graph of f of x to that of g of x. And then we also to make clear the order in which the transformations are applied. So this question goes from, or this graph goes from the solid lines to the breaking lines. Right? So it means that this one was done first before the one on top. Right? So we need to identify all the transformations that were applied to f of x to give g of x. But then first of all, what we're going to do is that we're going to identify every single transformation that we see over here before we write them in the order in which they were applied. So first of all, the fact that the g of x is not at the same place as f of x means there is a translation, right? So there is, and it's gone upwards. It means there is at least a vertical transformation translation. So first of all, we have a vertical translation, or generally we have a translation. Okay. So vertical translation would mean that the x component to be 0 and then the y component to be the translation vector, the number of uh, times of boxes by which the graph was translated vertically, and going to be positive because it is shifted upwards. Then we also look at some we compare some similar positions, right? So for instance, if we look at the top of this graph over here, it corresponds to the top over here. So even after the upward shifting or the vertical translation, we see that the top here, right, is not at the same level over here, right? It's not on the same line at x equal to 2, but then it's at the right side. It means there is also a horizontal translation. Um, So that means that the vertical part, the y part is going to be 0, and then the x part is going to be a number b. Right? So that translation was done to the right. So the number b must be a positive number, right? Because it has been shifted rightward. Then we also look at, so that's for translation, how the curve has been shifted from one point to the other, one position to the other. Then we also look at the original curve, right? From, for instance, you can check from here, right? You see how that this line um, is steep, but it's steeper than the translated one. So at f of x, from here to here, covers about 1, 2, 3, 4, 5, 6 horizontal boxes or lines, or 6 rows. But then over there on d of x, it covers less than 6. I think it covers about 3 of them. So it tells us there has been a stretch, but then this stretch was not outward but then inwards, right? So it is stretched along the vertical axis. So there is a vertical stretch, which means that the function f of x has been multiplied by a certain number. And because d of x has been reduced in terms of the stretch, it means that that number must be a fraction. Vertical stretch must be a fraction. So the stretch factor k must be a number less than 1, but then also greater than 0. So we have these three transformations that have been applied: vertical translation, horizontal translation, and then a vertical stretch. And of course, we can combine the two translations to translation by the vector AB, which we're going to look at very soon. Then a vertical stretch. And I know all these three transformations have been applied. We need to find out how do we write them in the order in which they are applied. Since they are we have two vertical and one horizontal, we need to know which one needs to be applied first before the other. Of course, you can also try to check if there is horizontal stretch as well, but then there's nothing like that. How do we even find that one out? Look at how long this graph stretches, right? So on the x-axis, it goes from this line from 0, right, to 6. That means yeah, from 0, the original one goes from 0 to 6, and then the transformed one also goes from 1 to 7. So the same 6 intervals, right? So it means there hasn't been any form of horizontal stretch. Yeah, so now we go back to the three transformations that we found and find out which ones are we going to apply first. So first of all, we have um, two vertical transformations, which is a vertical stretch by a factor k, and then a vertical translation by the vector 0a, right? So when two vertical transformations are applied, you follow the usual order of operation, like board mass or bed mass or ped mass. So for it, write board mass, BODMAS. Right? So think of stretch as multiplication, because vertical stretch you do multiply the function by a stretch factor. Same applies to horizontal stretch. So think of stretch as multiplication, and think of translation. Translation is either we add or subtract. So think of translation as addition or subtraction. Right? So between multiplication and addition, we see that multiplication comes first before addition. That means that we are supposed to apply the vertical stretch first before the vertical translation, and then the horizontal translation. Or we apply the vertical stretch first and then horizontal translation before vertical translation. So if it were two horizontal transformations, then we go the reverse direction of body mass. So if it's horizontal transformation, two horizontal transformations, then we go the addition before the multiplication. That means that horizontal stretch and then the horizontal translation. We would have done the translation first before we do the stretch. But since these two are both of them are vertical, we do multiplication, which is the stretch first before the translation, which is addition or subtraction. And once the vertical stretch is done already, then we have a vertical translation and horizontal translation. Between the two, you can do any one of them first, or you can even add both of them and do them at the same time. You still get the same results. So now we know we are going to start with vertical stretch. So let's find out what the stretch factor is. So transformation number one is vertical stretch. So by O be the scale factor. So the scale factor, let's say that is K, right, is equal to, so remember it's going to be image over object, right? The transformed curve over the original curve. And by that, what I mean is that pick any two corresponding sides. As I'm going to pick this side and then this side. However, we can also decide to pick any other two sides, but then what you can pick is the last part of the curve. You can't pick this part, this horizontal part and this horizontal part, because they wouldn't help us find any information about the vertical shape, because both of them are horizontal and they have no form of information for us to identify the vertical stretch. So we're going to, the only two possible places that we can use are this side and then this side. So we're going to do that. And by image over object, what I mean is that we're going to find out how many lines, right? How many rows does this part cover, right? How many rows does this part cover on the original graph on f of x? So we read it from the vertical axis. So right from the top here is -4, all the way down here to -10. So the difference is 6. Right? So we're going to find the absolute difference. So that is for the object. Then we check the corresponding side. So that part corresponds to this side, and up here is 3 here, and then all the way to 0. That is about 3 rows, right? So originally this part, these two corresponding sides, originally this part covered up to 6 lines, but then the transform graph covers up to 3 lines. So what we're going to do is this. So our vertical stretch is K is equal to, the object covers up to 6 lines, but then the corresponding side of the image covers up to 3 lines or 3 rows. That makes the vertical stretch factor half. So this graph g of x um, was transformed from f of x by a scale factor, a vertical stretch by scale factor of half, and that gives us, or that completes the vertical stretch part. So we need to move on to the translations. Now, before we apply the translation, we we're gonna ask ourselves what will happen to the curve after the stretch is applied, right? We said the curve is going to be, or the vertical stretch is by a scale factor of half. We're going to apply that um, factor, or that transformation, to f of x and find out what will be the results after that transformation, or that stretch has been applied, before we identify the horizontal and then the vertical translations. So because the stretch is vertical and by half, we just pick the some important parts of the curve, right? And then apply the half to it. And because it's vertical, it's only going to affect the vertical axis, which is the y component. So we pick this point first. The y component here, or the y coordinate here, is 10. Half of 10 is 5, or half of negative 10 is negative 5. So it means that after the stretch is applied to this part of the graph, it moves to negative 5 somewhere here. So negative 5 is here. Then up here at the apex here, or at the maximum point here, the y coordinate here is negative 4. And then after the stretch is applied, that is times half, it will move to negative 2. So that has to be somewhere here, right on top of it. Then we also identify for this part as well. And after the y value here, or the y coordinate here, is negative 6, and by half we get negative 3. So this part moves to negative 3. Remember, even though it is moving, but then that is still not a translation, so a stretch. So this part moves to a negative 3, and that is somewhere here. Negative 3 is here. Same applies to the last part, the end of the graph, that's also negative 3. That means that after the stretch is applied, our curve is expected to move this way, come here, be here, come all the way here, and then lie on this line up to this point. So this is our graph after the vertical stretch has been applied. Now we can easily identify the vertical translation and then the horizontal translation together, or one after the other. So now we can pick any two corresponding sides, right? So for instance, if I pick the starting point of the graph somewhere here, we find out how many boxes has it moved to the each new point somewhere here, right? So at negative 5, it moves all the way to 0. Then it moves rightwards to 1, right? So you see that it moves by 5 units up, and then by 1 unit to the right. Okay. You can also check a different points. For instance, if you want to check the end of the graph over here, right? How many times does it move up here? So over here it is at negative 3, and then it moves all the way to positive 2. That is exactly 5. So right from here to here is plus 5, and then the final part is here. It moves here by 1. So it means the translation is 5 units up, which is on the vertical axis, and then 1 unit right, which is on the horizontal axis, and this becomes our translation. So we finalize our answer by writing that's number 2. So you may have three transformations by way of trying to separate the two translations, but then I'm going to combine them over here. So then translation by the vector, or by the translation vector 1, 5, and that's completes the sequence of transformations as well as the order in which they were applied. Now B, find an expression for g of x in the form of this, right? So we've already identified the transformations. We said we have a vertical stretch of half and then a translation by the vector 1, 5. And the A here is a vertical stretch. B is a horizontal translation, and then C is a vertical translation. So it means g of x is equal to A, which is the vertical translation, and that is half. And then f of x and B is a horizontal translation. And remember, because it is horizontal for a horizontal translation, if f of x is translated by the vector a0, the new function, let's say f1 of x, f1 becomes f1 of x minus a. So it is positive here, but when we send it inside the function, inside the bracket, it becomes negative. So the translation was 1, 5 over here. But then once it comes here, b is a horizontal translation, becomes minus 1. And C is a vertical translation, which is 5. And it maintains its positive value, unlike the horizontal one. That is the final value or solution for question 2b. Now question 3. The perpendicular bisector of the line joining 4, 3 and negative 2, 6 meets the line at the point P. Find the coordinates of P. So we first of all need to find the perpendicular bisector of these 2 points. So we have two keywords. We have perpendicular and we have bisector. Right, so perpendicular means we are going to take care of the gradients of the line joining these 2 points and then find the negative reciprocal. Bisector means that that line we are looking for passes through the exact midpoint of these 2 points. Right, so we need to find the midpoint first. So the midpoint of this is, we add the x components 4 plus negative 2 and then 3 plus 6. Divide both of them by 2. Then we have 2 over 2 is 1, and then 9 over 2 or 4.5. So the new line that we are looking for passes through this point, this midpoint. Now you also find the gradient of these 2 points since we are looking for the perpendicular bisector. So the gradient m is equal to change in y, which is 6 minus 3, over change in x, negative 2 minus 4. That gives us 3 over negative 6, and that is negative half. But because we are looking for the perpendicular bisector, the gradient of the perpendicular bisector is going to be the negative reciprocal of the gradient of the line joining these 2 points. So I'm going to write that gradient of perpendicular bisector is equal to the negative reciprocal, so negative of negative 1 over 2, and that gives us positive 2. Now our equation of the perpendicular bisector is y minus y1. So I have y minus y1 equals m x minus x1. Right? But then y1 is 9 over 2. And then the gradient here is 2, x minus x1, and that is 1. So we expand, or we can make y the subject. Since we are going to solve a simultaneous equation in the end, you can make x or y the subject of this equation. So let's first of all expand this. We have y is equal to, so I'm going to send the 9 over 2 to the other side, so that I have 2x minus 2 plus 9 over 2. We have y is equal to 2x, and then 9 minus 4 is 5. So we have plus 5 over 2 for this equation. Now we need to solve this equation and then the one given simultaneously. But then I think I see negative 4y, or I see a 4y here, and over here we have made y the subject. So what I'm going to do is that, as a matter of fact, there are many ways that you can solve this. Okay, but I'm going to go this way because I see 4y there. I'm going to multiply this whole equation by 4, right? So that I see 4y here and I do direct substitution, or I can even try elimination, and it's going to work. So I'm going to multiply this whole equation by 4, so that I have 4y is equal to 8x plus 10. Right. Now I go back to this equation, the one given in the question, and wherever I see 4y, I replace that by 8x plus 10. So that equation is x minus 4y minus 4. So in x minus 4y minus 4 is equal to 0, I'm going to get x minus the 4y is now 8x plus 10 in brackets, then minus 4 is equal to 0. Now we have here x minus 8x minus 10 minus 4 is equal to 0. Now this is going to be negative 14. To the other side, we can positive 14. Then we have negative 7x is equal to 14. Divide both sides by 7, negative 7. And x is equal to negative 2. So x has been found. Now we do substitution into this equation, or any of the equations, to find the value of y. Now y is equal to 2x, so that's 2 times negative 2, then plus 5 over 2. That's going to be negative 4 plus 5 over 2, and that is 5 minus 8, that is negative 3 over 2. So now the point P, where the two lines meet, is negative 2 and then negative 3 over 2, and that is our solution. And for question number 4, find the first three terms in ascending powers of x in the expansion of this binomial. We're going to apply the binomial here, or binomial expansion over here, right? So yeah, so the first term is at A, the second term is at B, in this order. So we have over here, since we are to go in ascending powers of x, our first term, our A, is supposed to be the number, but if we were to go descending, then our A would have to be the term that has the x attached to it. So we see here that n is equal to 4. Our b is the whole of negative half SNN. Our a is the number 3. We're going to expand that. So we start. We have 4. The first term, as we saw over here, is supposed to be a exponent n, or 4 combination 0, and then the other stuff as well. So yeah, we start from 3 exponent 4, then plus 4 combination 1, and then 3 exponent 3, and negative 1 over 2 x exponent 1. Remember, the exponent here and the one here must add up to n, which is 4. Then the last term, as far as this question is concerned, is 4 combination 2, 3 squared, and then negative 1 over 2 x all squared. It goes on and on, but then we are required to produce the first 3 terms. 3 exponent 4 is 8 to 1. 4 combination 1 is 4. Then times 27. Then negative 1 over 2 x. Then 4 combination 2 is 6. 3 squared is 9. And then times 1 over 4 and s squared. So finally, the first three expansions of this binomial is 81 plus 2 times 27 is 54. But because of the negative here, it has to affect this, giving us negative 54x instead of a positive one. So I'm going to write negative down here. Then finally we have um, 54 over 2. That is 27 over 2 x squared. And that is the first three expansions of this binomial. Then B also says that we have to find the first three terms once again in ascending powers of x in the expansion of this binomial. So here our n is 3, our a is 2 since we want to go ascending, and b is ax only. Right? Then we go, the first term is 3, 2 exponent 3, and then plus 3 combination. I'm going to use the C notation. 3 combination 1, 2 squared, and then ax exponent 1, plus 3 combination 2, 2 exponent 1, ax all squared. It goes on and on, but we need to just produce the first three expansions. We have 8 plus 3 combination 1 is 3. So ax plus 3 combination 2 is also 3. A squared, s squared, and plus this. So finally we have 8 plus 12ax, and then plus 6a squared, s squared as the expansion or the first three terms in ascending powers of x in the expansion of this binomial. And question number 4b, it says that it is now given that the coefficient of x squared in the expansion of these two binomials is negative 108, and you have to find the value of a. So I just wrote the expansions we've already done over here. Right? So we found out that the first three terms of this binomial is this, and then the second one is also given over here. And when we multiply the expansions, the question says that the coefficient of x squared after this multiplication or this expansion is going to be negative 108. So what we need to do is to find out which terms are supposed to be combined to produce the x squared term. So we start from the first one. We know the the positive 81, the first term, when multiplied by the last term over here, right? This is x squared as well. When multiplied by the last term over here, will produce a x squared, one x squared term. So we know 81 times 6a squared. Right? Then we also know this, the second term here, negative 54x times 12ax. When multiplied, we also produce an x squared term. Right? We don't need to bring the x squared because we just need the coefficient. So the next one is going to be negative 54 times 12a. Then finally, the last term, the first term of the last expansion, 8 here, times 27 over 2 will also give us x squared term. So the last one is plus 8 times 27 over 2. And when we expand this, the question says we have to get a negative 108. So now we need to simplify and solve this quadratic. We're going to multiply through. We have two ways. You can decide to multiply through, get the huge numbers, and then work on them, which is possible. Or if possible, try and reduce the coefficients by dividing through by a common factor so that the numbers get reduced. I'm going to divide it by a common factor. But I know I see 81, 54, 27, and 108. I think 9 is a factor of all these numbers, right? So, or 18 because the other numbers are even numbers as well. And actually, 54 can divide all of them, right? I'm going to go um, 9 first. So I'm going to divide every other term by 9. So this whole thing divided by 9. So the first one, 81 by 9 is going to be 9 again, and then times 6a squared. Then next is 54 by 9 is 6, and times 12a. Then plus 27 by 9 is 3, so you have 8 times 3 over 2. And then lastly, 108 by 9 is to be 12, right? Then I can either also multiply the numbers and then get my quadratic, or still decide to reduce the fractions, the coefficients. And I think 6 will divide every other number. I'm going to divide through by 6 also, divided by 6. So for the first one, I have 9 out and then a squared because the 6 takes out the 6. Then minus 6 takes out this and I have 12a. Then over here, dividing by 6, 8 times 3 is 24. Divided by 2 is 12. 12 by 6 is 2. So plus 2. Then at the other side of the equal sign, this by 6 is going to be negative 2. So finally, we can have our reduced quadratic 9a squared minus 12a and then plus 4, since the 2 will move to the other side. These are quadratic and I'm going to solve for the values of a. So I'm going to go 4 is 36. So we can use negative 6 and then negative 6. Have 9a squared minus 6a minus another 6a plus 4 is equal to 0. We pair and factorize. 3a is a factor. I have again 3a here minus 2. Then 2 is a factor. 3a minus 2 is equal to 0. So you have 3a minus 2 and then another 3a minus 2 equal to 0. And from both of them, you find that a is equal to 2 over 3 repeated. That's the value of a. So question number 5. The equation of a curve is such that the second derivative is given by c squared plus b, where p is a constant. The curve has minimum points at these 2 points. You have to find the other coordinates of the stationary points of the curve. So first of all, how do we find stationary point of a curve? Well, say we have a curve y is equal to a function of x. We find the stationary point by, or the minimum points by, first of all finding the first derivative and then equating to 0, right? So it means that this is exactly what was done. They found the first derivative, equated to 0, found the values of x to be 2 and then negative 2, but then there was still an extra value of x missing, which we are supposed to find together with its corresponding y value. But what we have here is the second derivative. Meanwhile, the first derivative was used to find the stationary point. So it means that we need to get the first derivative and then go through whatever calculations they did just to get exactly what they found over here. And since we have the second derivative, we need to integrate to find the first derivative. Let's start. The first derivative can be found by integrating the second derivative with respect to x. That is the integral of 6x squared plus p with respect to x, and that is going to be 6x cubed over 3 plus px, and then plus the constant of integration since there are no limits of integration over here. Now the first derivative is 2x cubed plus px plus c. And how do we find the stationary points? We equate the first derivative to 0, and after that was done, the results they had were 2 and then -2, and there was still one value missing. That's what we're supposed to. So what we're going to do is that we are going to substitute 2 and then -2 into the first derivative and then equate it to 0. So we have here when x is equal to +2, we have 2 out 2 cube plus 2 out and then p plus c is equal to 0. That gives us 16 plus 2p plus c is equal to 0. Now we can rearrange and then write 2p plus c is equal to -16 as our first equation. And then we also substitute x is equal to -2. That gives us once again 2 here by -2 cube plus p out and -2 in the brackets plus c equal to 0. This is -16. Then minus 2p plus c is equal to 0. Then by rearranging, we get -2p plus c is equal to +16. And this is our second equation. And we can solve these two equations to get the values of c and p. And it's easy because 2p is over here positive and negative here. So we just need to add equation 1 and equation 2. So equation 1 plus equation 2. 2p plus -2p is 0. C plus c is 2c. Then -16 plus 16 is 0. And that implies that c is equal to 0. We put that into any of the equations. I'm going to put that inside this equation. Then I have -2p is equal to 16 since c is 0. Then this implies that p is equal to -8 after dividing through by -2. Now you can rewrite the second derivative by replacing their c and p by their respective values. So the first derivative, is equal to 2x cubed plus px, and now p is -8, so -8x, and c is 0, which is better not written. So this is the first derivative from which x equal to 2 and then x equal to -2 were found. So what we need to do is to find the other x value, right? Once again, we find the stationary point by equating this to 0. So we do that and find the other missing x value. So we have here 2x cubed minus 8x is equal to 0. We can divide through by 2 by 2. And what we have is x cubed minus x is equal to 0. We factor out x and we have x squared minus 1. Sorry, so there's 4 here. So they have x squared minus 4 is equal to 0. So from this we have x is equal to 0. And the other one, x squared minus 4 will give us x equal to 2 and x equal to -2. And these were the values that we've been given already. So it means the missing x value we're looking for is x is equal to 0. Now that has been found, but then we're asked to find the stationary point. That means that we need to find the corresponding y value of this x is equal to 0. But we do not have the equation of the curve here, so we also need to integrate the first derivative to find the curve itself. So we integrate y is equal to integral of 2x cubed minus 8x with respect to x. That gives us 2x exponent 4 divided by 4, then minus 8x squared divided by 2 plus our constant of integration. Let me use k. Then we have here y is equal to half x exponent 4 minus 4x squared plus k. Now how do we find k? We're given 2 points initially, that is 2 and then positive 3, and then negative 2 and positive 3. So you can use any of them to do a substitution here, and then we get the value of k. When x is 3, when x is 2, y is 3. So that will imply that we have y is 3 here and x is 2. So we have over here half 2 4 minus 4 times 2 squared, and then plus a k. Right. So that gives us 3 over here is equal to 16 over 2, and that is 8. And this is 4 times 4, that is 16 plus k. Now we have k is equal to this negative 8, so it goes to the other side, and then we have 11. K is 11, right? So it means I'm going to change the equation of the curve and then replace k by 11 as we found its value. So k here is 11 here. Now we need to find the value of y when x is 0. When x is 0, y will be, everything here goes to 0, y will be 11. Then the other stationary point that the question requires us to find is 0 and 11, and that's the final answer. Now question number 6. To solve the equation this. So since we find cos inverse of A, we start off by taking the cosine of both sides. So that at the left hand side we have sine squared of x plus 3 over 2 sine x is equal to cosine of the test by. Right. We have sine squared of x plus 2 over 3, so 3 over 2 sine x. And then cos of the test by has to be negative half. So negative 1 over 2. Then we also need to clear the fractions since you have a quadratic. So we clear the fractions and then we solve, or you can still solve it without clearing fractions. I'm going to clear fractions. We multiply through by 2. Then we have 2 sine squared x plus 3 sine x. Then this is going to times 2 is going to negative 1. I'll bring it to the other side. I have positive 1 is equal to 0. And if you think it's going to confuse to work in sign, you can decide to replace an x by a variable, let's say a y or an a. Work through, and when you finish you bring back your substitution. So we have two factors of 2 are 1 and 2. So we have 2 sine squared x plus 2 sine x plus another sine x, making this 3 sine x. And then plus 1 is equal to repair and factorize. 2 sine x is common to both sides. We have 2 here, sine x out, we have sine x plus 1 in one bracket. And 1 is common to both sides, so sine x plus 1 equals 0. So we have 2 sine x plus 1, and then sine x plus 1 is equal to 0. We equate each one of them to each term to 0, so that we have first we have 2 sine x is plus 1 equals 0, or sine x plus 1 is equal to 0. So we have sine x from here is equal to negative 1 over 2, and here sine x is equal to negative 1. Then now you're going to point this on the calculator, but then you also need to check the domain. The domain is 0 less than or equal to x less than or equal to 2 pi. That's 0 and 360. So make sure on your calculator the angle mode is in radians as you punch this. Or if you work in degrees, you also will be required to change it back to radians. So let's find for the first one, x is equal to sine inverse of negative 1 over 2. So what I would have you do is that you're going to point sine inverse of half instead of negative half, and then you write down the value. Okay. Then you find out which quadrants you are going to find a solution. So let me draw that over here. Because sine of x, we are looking for x as an angle. Sine of a certain angle is negative. That means that we are going to find a solution from the quadrant in which sine is negative. And that is the third quadrant here, and then the fourth quadrant. So on a calculator, you point sine inverse of positive half instead of negative half. Yes, I've written negative half, but then you point positive half, and then the result is going to be pi over 6. That's 30 degrees. So you draw the pi over 6 in this quadrant. That's 30 degrees if you want to work in degrees. So pi over 6, and then in the fourth quadrant also pi over 6. Then you read from the positive x-axis all the way to this line, and that's going to be from pi plus pi over 6, right? So pi plus pi over 6 is 7 over 6 pi, right? So 7 over 6 pi. Then next is you also read from the positive x-axis all the way to this line, and that is 2 pi minus pi over 6, right? So that is 11 pi over 6. So these are the two values within the range given between 0 and 2 pi. Now next is sine x equals to negative 1. Once again, you can decide to point the positive part only, so that your answer will not be negative, which will be outside the range, the domain. So x is equal to sine inverse of negative 1. You point sine inverse of 1, and then the result is 270 degrees, or 3 over 2 pi, and no more values in the range. It means that the values of x that satisfy this equation are 7 over 6 pi, 3 over 2 pi, and then 11 over 6 pi. Number 7a. The second, fourth, and last terms of an AP are 60, 52, and then negative 28. So it is an AP. You have to find the sum of all terms, right? The sum of all terms will progress. We're given the second, the fourth, and then the last term. Remember, for an AP, the nth term, which is the same as the last term, is equal to the first term plus the n minus 1 and times the common difference. And from that, we know the second term, that is u2. The second term is a plus d, and that has been given as 60. That gives us one equation. The fourth term is a plus 3d, that is 52. And then the last term, which is L, has been given as negative 28. So since it is the last term, we don't know what value of n gives us the last term, but then the term itself has been given to us. So we just need to write that into the formula, and then we find what value of n will be. So the last term, or a plus n minus 1d, is equal to 28, negative 28. We are going to use the first two equations, equation 1 and equation 2, to find the values of a and d. And after finding those values, we use them to find the value of n that gives us the last term, which is negative 28. So we're going to go the second equation, equation 2 minus equation 1, knowing that that would eliminate a. So the second minus first, so a minus a is 0. 3d minus d, then equal to 52 minus 60. That gives us 2d is equal to negative 8. And then d is equal to a negative 4. You can substitute that into the first equation to find the value of a. So from that, we see that a is equal to 60 minus d. That is 60 plus 4. That is minus 4. So a is equal to 64. So our first term is 64. Our common difference is negative 2. That means our AP is reducing as we increase the terms. Now, the values of a and d will be used to find the value of n in the last term. So I'm going to substitute both of them, a and d, into the third equation over here. So we have a is 64 plus n minus 1, and our common difference is negative 4, equal to negative 28. I'm going to divide through by a negative 4. Right, so here by negative 4, here by negative 4, here by negative 4. Then I have negative 16 plus n minus 1. Of course, we could have so expanded and grouped them and found our n, and we'll still get the same result. Is equal to negative 28 over negative 4 is positive 7. Now let's find n. N is equal to 16 plus 1 plus 7. So that is 16 plus 8, and that is 24. So we found the value of a D, and then N. A is equal to 64, D is equal to negative 4, and N is equal to 24. Means that there are exactly 24 terms in this sequence, and that's 24th term, which is the last term, is negative 28. You have to find the sum of all terms. You have to find sum of all those 24 terms, and that is going to be, and we know sum of n terms of an AP is n over 2 into bracket a plus l, given that the last term is known. So this is going to be n, which is now 24 over 2. Then a is 64 plus the last term, which is negative 28. That gives us 12 out, and 64 minus 28 is 36. So 12 times 36 gives us 432, and that is the sum of all the terms of the sequence. On to question number 7b. The second, third, and fourth terms of a GP are given by these values respectively, where k is a negative constant. So we notice first of all that this is a geometric progression. So this is a GP, and then the value of k is also a negative number. Remember, for a GP, the nth term of a GP is given by the first term times the common ratio exponents n minus 1. Right? So by this formula, we know the second term, which is u2, means that we're replacing n by 2 over here. That gives us 2 minus 1, and that is exactly AR. So the second term is 9. That means that AR is equal to 9. And that is one equation. Now next is the third term, which is by the same formula is going to give us AR squared is equal to k plus 4. This is the second equation. And lastly, the fourth term, which is AR cubed, is equal to k squared. And I'll name this equation 3. Now we are to find the value of k, right? So unlike the previous question where it was an AP, so we needed to solve simultaneous equations by using either substitution or elimination. This one too, we can decide to use substitution to find our values, but then it is way easier and faster to be dividing the equations when they are coming from a GP. Right? So what we're going to do is that we're going to divide one equation by the other. So I'll start with equation 2 divided by equation 1, and that gives us, so I'm dividing 2 by 1, so we have AR squared then over AR is equal to k plus 4 divided by 9, right? So by this we see that a and a will be cancelled out, and r will take one r out, so that we have r is equal to k plus 4 divided by 9 as one other equation. Then we do a similar thing with any other two equations apart from 1 and 2. So we either pick 1 and 3 or 2 and 3. We're going to pick 2 and 3 because I know if I divide 3 by 2, I'm still going to have an expression for r. So I'm going to do equation 3 divided by equation 2, and that gives us AR cubed over AR squared is equal to k squared over k plus 4. And here again, a and a are gone, and we have only one r left. So from this, you have r is equal to k squared over k plus 4. So here we have two expressions or two equations for r. R is equal to this, and at the same time r is equal to this. Then these two equations must be the same, right? That means that k plus 4 over 9 is the same as or is equal to k squared over k plus 4. So we do cross multiply and then find our k. We have k plus 4 all squared is equal to 9k squared. At this point, you can decide to take square root of both sides, right? If you take square root of both sides, the left hand side is going to be k plus 4. And the right hand side is going to plus or minus 3k. Then you separate the plus and minus and you solve them. You're going to get two values for k, but you picked only the negative parts. But I'm going to go by a lengthier approach where I'm going to expand the k plus 4 in the brackets. So by expanding this, we have k squared plus 8k plus 16 is equal to 9k squared. Right, so we group everything to one side and then we solve a quadratic equation. So I'm going to do that down here. I have 8k squared minus 8k minus 16 is equal to 0. And I believe you can divide through by 8 so that we reduce the coefficient, or we can still solve it right away from here. You have k squared minus k and then minus 2 is equal to 0. So over here we have 2, negative 2 and then positive 1. So k minus 2, k plus 1 is equal to 0. We equate both of them to 0, but we know the first one is going to give us k is equal to 2, but the question says that k is negative. So we need to only pick the value or the expression that gives us a negative value of k. So k here is equal to a negative 1, and that is our final answer for part BI. Now for BII, find the sum to infinity of the progression. And this is also a GP, right? So for a GP, the sum to infinity is given by the first term over 1 minus r, right? So let me write that over here. Sum to infinity is equal to a over 1 minus r. It means we need to find our first term. We also need to find our common ratio. But then having found the value of k to be negative 1 here, we can substitute that into any of these two formulae to find the value of k. Once find the value of r rather, and once that is found, we use any of the three equations to find the value of a. So let's start off with r. R is equal to k plus 4 over 9. Or r is equal to k plus 4 over 9. But k is negative 1. So negative 1 plus 4 divided by 9. That gives us 3 over 9. And that is 1 over 3. Then we also know from the first equation that AR is equal to 9 and R has been found to be 3. So we have A over 3, or A times 1 over 3 is equal to 9. That implies that A is equal to 27. That's 9 times 3. Now that you have A and R, we can find the sum to infinity as equal to our A, which is 27, over 1 minus our r is 1 over 3. So we have 27 over 2/3, and that is 27 times 3 over 2. And that's finally we have 81 over 2. Or you can write 40.5 as a sum to infinity. Now question number 8. The diameter of a circle has endpoints -2, 4, and 8 is find an equation of the circle. So let's assume that circle is over here. You don't need any sketch, but just to see things clearer. So, and then this is our diameter. Here is 8 and 8, and then this part is -2 and 4. So at the midpoint of the diameter is the center of the circle. Right? And we know to find the equation of a circle, we need the center. So equation of a circle in the completed square form is x minus a all squared plus y minus b all squared is equal to the radius squared, where a and b are the coordinates of the center. It means we need to find the midpoint of the diameter, right? So the center is the midpoint of these two coordinates given. So 8 plus negative 2, so that's 8 minus 2, then over 2. And the other one, 8 plus 4 over 2. That gives us 6 over 2, that is 3, and then 12 over 2, that is 6. So that's the coordinate of the center, where 3 represents A and then 6 represents B. Now that we have the center, we can find the um, radius by finding the distance between the center and then any of the two endpoints of the diameter, or better still, we can also find the distance uh, between the 2 points given over here. Then we have it to find the radius. So I'm going to pick the center and then -2, -4 to find the radius. So our radius is equal to square root of, so remember the distance formula, it has to be change in x squared plus change in y squared. So our radius is first 3 minus -2, so that gives us 3 plus 2 all squared, and then plus 6 here minus 4. So 6 minus 4 all squared. Now we have 7 squared, no 5 squared, so 25, and then 2 squared, 4. So the radius is 29, root of 29 units. Now that we have the center and then the radius, we can easily find the equation of the circle. So that is going to be x minus a, which is 3, all squared, plus y minus b, which is 6, all squared, is equal to root of 29 squared, and that is going to be 29. So this is the equation of the circle in completed square form. If you like, you can also decide to expand, right, which is not really a compulsory. You can decide to expand everything and get x squared plus y squared minus 6x, and then minus 12y, then plus 9 plus 36 minus 29, we have plus 16 is equal to 0. So this is the expanded form of the equation. Now question number 8b says that the line with equation y equals x plus 6 intersect the circle at 2 points P and Q. Find the exact distance between P and Q, and our answer must be left in set form, right, where A and B are both integers greater than 1. So first of all, remember the equation of a circle as we found previously in the completed square form was x minus 3 all squared plus y minus 6 all squared equal to 29 over here, right? And then we need to solve this circle and then this line simultaneously, right? So we're going to substitute y equals x plus 6 into the equation of the circle, which means that wherever we find y, we replace that by x plus 6. I'm going to do that over here. We have x minus 3 all squared plus, so there's y here that is going to be replaced by x plus 6 before this -6 will appear here, all squared is equal to 29. So we have x minus 3 all squared, then plus here we'll have x squared only left over here. I'm going to send the 29 to this side so that we have negative 29 is equal to 0. Then we can expand the first term. X squared minus 6x plus 9 plus x squared again minus 29 is equal to 0. Now you simplify, we get 2x squared minus 6x and then minus 20 is equal to 0. So you can factorize it straight ahead, or you may want to divide through by 2 so that you reduce the coefficient. I'm going to do the dividing through by 2 so that we have x squared minus 3x minus 10 is equal to 0. Right. Then so 10 we have 5 and 2. X out, negative 5, x here, and then plus 2 is equal to 0. We have two values for x. X is equal to 5 in this one, or x is equal to negative 2 in this one. So from both of these, x equals 5 and x equals negative 2, we substitute each one of them into y equals x plus 6, which is the equation of the straight line given. Do the same thing for the other one, y is equal to x plus 6. So for the first one, when x is equal to 5, y is equal to 11. And for the second one, when x is equal to negative 2, y is equal to 4. So that means that our point P and Q, so any of them can be your P and then the other becomes your Q. P is 5 and 11, and then Q is negative 2 and then 4. But that's not the final thing because we are asked to find the distance PQ, or distance between P and Q. So the distance PQ, or the line PQ, is square root of the difference between the x component squared. So that's going to be 5 minus minus 2. That's going to be 5 plus 2 all squared. And then 11 minus 4 all squared. So we have 7 squared plus another 7 squared, both of them under the root sign, which is equal to, we have 2 7 squareds, or 2 times that's 49, and the root of 7 squared is 7, root of 2. So this is our pan A with B. A is equal to 7 and B is equal to 2. And remember the question said both are integers greater than 1. And that is the distance between P and Q. So question number 9a. First of all, the diagram shows the curve with equation y equals 2x plus 1. The normal to the curve at the point 49. And then a line y equals a, also given over. So this y equals a, and this is a curve whose equation is given 3 root of 2x plus 1. And then this straight line is the normal to the curve at the point 49. We have to find the area of the shaded region. So we see that the shaded region is found below the curve, right? Below the curve y equals 3 root of 2x plus 1. And then also between the x values 0 and then 4. Remember, r is 49, so the x component, the x coordinate of this point is 4. So here is 4, and then up here is 9. But what we really need at this point is these two values on the x-axis. So it means to find the area on the shaded region, we need to integrate the function y, which is equal to 3. I'm going to write the 2x plus 1 under the root sign exponent half with respect to x all the way from 0 to 4. We can evaluate this integral and then we find our solution. So we go, 3 can be written outside since it's a constant.
0, 4, and then 2x plus 1 exponent half, and then dx. So you're going to integrate it as a reverse way of doing the differentiation. So the area is, so here's area. So the area is equal to 3 out, and then the integral of this is, we write the entire function again, and then we add 1 to the exponent. So half plus 1 is going to be 3 over 2. Now divide by the new exponent 3 over 2 times the differential of the inside function. So the differential of 2x plus 1 is 2. So that multiplies this. Then we have 3 out, and then the limit as well, 0 to 4. 3 out, and then inside the bracket you have 2x plus 1 exponent 3 over 2 all over. So 3 over 2 times 2 will give us 3 over here from 0 to 4. So at this point, you can substitute as 0 and 4, or better still, you can also write the 3 outside. So if I write the 3 outside, I'm going to have 3 out of 3, or 3 over 3 outside, which is going to be 1. So I'm going to ignore that and write a is equal to 2x plus 1 all exponent 3 over 2 from 0 to 4. So let's substitute 4, and then we'll substitute 0. Then you find the difference as well. The area is equal to replace x by 4 into this function, we have 2 times 4, which is 8, and then plus 1. All exponents 3 over 2 minus 2 times 0, which is 0, and then plus 1. All exponent 3 over 2. Then we have area, so inside the brackets 9 exponent 3 over 2 minus 1 exponent 3 over 2. So 9 exponent 3 over 2 is going to be, root of 9 is 3, 3 exponent 3 is 27, 27 minus 1, and that is 26. So the area is 26 square units square, and that is the area of the shaded region in this curve. Now for question 9b, find the exact value of A for which the triangular area enclosed by the y-axis, the normal to the curve at R, and then the line y equals A is equal to the area found in 9a. So first of all, the area we found in 9a was, that area is equal to 26 square units. And then we have to find what value A should be, so that the area of the triangle between the y-axis, so there's a y-axis, in the other curve, so there's the whole of y-axis, and then the normal to the curve at R, which is this slanted line, and finally the line y equals A, which is this line. So it means you're talking about this triangle, the triangle at the top here. So let me name A, B here, and then C, just for identification purpose. So we want to find what value A should assume, so that the area of this triangle at the top here will be equal to 26 units squared, and we know area of a triangle should be equal to half base times the height. So we need to find the base of this triangle, which is supposed to be where C is. Find the value over here, then that will give us the base of the length of the base. Then the height we also need to find from small a all the way to where big A is. That would give us the height of this triangle. So we need to find first of all the equation of the normal to the curve. That way we'll be able to find where it intersects the line y equals a, and also know the y-intercept, which is exactly what we need to find the height. So we start by finding the equation of the normal to the curve, and since we are finding the equation of a straight line, we need to find gradient. Right, so we start from the curve y equals 3 into bracket 2x plus 1. So for y equals 3 in brackets 2x plus 1, which is the same as 3 in bracket and then in brackets 2x plus 1 all exponents half. Now dy dx, which is the general gradient, is 3 over 2 2x plus 1 exponent negative half then times 2, which means that we're going to have 3 divided by 2x plus 1 exponent half, which is the same as roots. So this is the general gradients. And then at r, which we find the normal passing through, x equal to 4. So at x equal to 4, the gradient of the tangent, so gradient of tangent at x equal to 4, which is the same as the gradient of the curve at r. That is given by 3 divided by root of 2 times 4 plus 1, that is 9. And that gives us 3 over 3, and we get 1. So that's the gradient of the um, tangent at x equal to 4. And we need to find, since the line is normal to the curve at r, we need to find the perpendicular gradients. So for perpendicular gradients, we find a negative reciprocal of 1, and that is negative 1. And we know the gradient of the line that passes through r and have a point at r. So we can easily find the equation of that line. So y minus y1, which is 9, is equal to m negative 1 x minus x1, which is 4. So we solve this, we arrange, and then we get y is equal to 9 plus 4, 13 minus x. So this represents the equation of the line, the normal to the curve at r. So this is y equals 13 minus x over here. Now at this point, it becomes easy to find the value of x at c, right? So just a matter of replacing y by a. So where y is equal to a, we find from this equation that a is equal to 13 minus x, and then the x value or x component is equal to 13 minus a. That means that at this point on the curve, this point is 13 minus a. That means the base of the triangle, or if you want to call it the height, that's fine, is equal to 13 minus a units. Now you also need to find the height. First of all, we find the point up here at a, right? That is exactly the y-intercept. So that is where x equal to 0. That means that y from this equation is going to be 13. So up here is 13. Now that means the height of the triangle is from the small a all the way to 13, and that's going to be 13 minus a. Now that we have the height and base of the triangle, we need to find area of the triangle. So the area of the triangle is half times base, and the base is 13 minus a times height. Height is also 13 minus a. But the question says what value should a be so that the area of the triangle will be equal to the area we found, which is 26. Now at this point, we rearrange and try to solve for a. So we do multiply through by 2 to clear the fraction, so that we have 13 minus a all squared is equal to 52. And we take the square root of both sides, square root of this and then square roots of this. So let's find a description of a. Okay. Anyway, a is positive, right? So we are going to only use a positive root of 52. So we have 13 minus a is equal to 52. Root of 52 is 4 times 13, so that is 2 root of 13. Now we make a the subject, so that we have a is equal to 13 minus 2 root of 13, and that is the exact value of a, so that the area of the triangle will be equal to, equivalent to, the area we found for the shaded region. And question number 10, a function f is defined by the expression over here, and then where the domain is x is any real number, where p is a constant. We have to find the exact values of p for which the equation f of x has repeated roots. So exact values, it means that p assumes more than just one value. So you're going to find all those values for which of p for which this equation has repeated roots. Right. So first of all, f of x equal to 0. That means we equate this whole thing, px squared minus 2x plus p plus 4 equals 0. So that becomes a quadratic equation. Now we can group it nicely and find what a, b, and c are. Our a from here is equal to p. Our b is -2, and our c is equal to p plus 4. By a, b, and c, I'm trying to compare it to the general form of a quadratic equation. A squared plus bx plus c is equal to 0. Right? And then for a quadratic equation to have repeated root, then the discriminant, which is b squared minus 4ac, must be equal to 0. So from here we do substitution of the values of a, b, and c into this discriminant, equate to 0, and find the values of p. So b is -2, that gives us -2 all squared minus 4ac. A is p, and then c is p plus 4. Okay. Then equals 0. Now at this point we can expand, or better still, because -2 squared is going to be 4 minus 4p, and then p plus 4. You either expand or you want to reduce the coefficient by dividing through by 4. So thus this equation becomes 1 minus p, and then into bracket p plus 4 equals 0. Right? Now we can expand and then find a solution to the quadratic equation. That's becomes the result. So let's expand. We have 1 minus p squared minus 4p is equal to 0. Or we can equally write as p squared plus 4p minus 1 is equal to 0. Then we use the quadratic formula to find the root, since we can't use factorization. So our p is -b, which is -4, plus or minus root of b squared, which is 4 squared minus 4 times 1 times -1 all over 2 times 1. Here we have -4 plus or minus root of 20 divided by 2. So our p is equal to -4 plus or minus root 20 is the same as 4 times 5. So that is going to be 2 root of 5 all divided by 2, which is the same as -4 over 2 plus or minus 2 root 5 over 2. And then p is equal to -2 plus or minus root 5. So these are the values of p for which the function or the quadratic equation given would have repeated roots. And for question number 10b, a function g is defined by the same expression as we found in 10a. For the domain x is greater than or equal to a, where p and a are positive constants, so that the least value of a for which the function g inverse exists is 1 over p. And so first of all, we need to be able to know g of x is a quadratic function. Right? So p is a positive constant, means that it's a minimum curve. This is not a one-to-one function. No quadratic function is fully a one-to-one function and a one-one function. If it's going to be one-one, then we need to restrict the domain, give a restriction on the domain so that we only talk about halfway through the curve, right? So all the way from here to this side is 1 1, and then the left side is 1 1, right? 1 1 function. So the domain given is x greater than or equal to a, right? So for g inverse, for the inverse of this function to exist, then this function must be 1 1, and the minimum value of x, so that this function will be 1 1, and for that reason each inverse will exist, is that x must be the vertex, or must be at the vertex of this quadratic. So all we need to do here is to find the vertex of this function. So for the vertex, sorry, the x value of the vertex, right? So x coordinates of the vertex is given by negative b over 2a, where our b is 2 and then our a is p. So that is negative 2 divided by 2p, and that is positive 2 over 2p. That is 1 over p. So the minimum point of this curve occurs at where x equal to 1 over p. So if you actually defined the domain, we define the domain so that this function would 1 to 1, then the domain is supposed to be such that x should be greater than or equal to 1 over p. So any number greater than or equal to 1 over p makes this function a 1 1 function, and for that reason, or for that matter, the inverse to exist. Remember, only 1 1 functions have their inverse existing. Apart from that, other functions that are not 1 1 do not have any inverse, right? So all values greater than 1 over p as a domain for this function will make the function 1 1, and so have make the function have an inverse, right? So the minimum of all these values, you see that show that the least value of a, right? The minimum of this value, so it means that this greater than or equal to 1 over p is what is represented by a over here, right? And the minimum of s greater than or equal to 1 over p is 1 over p. I show that um, we can conclude that the least value of a is equal to 1 over p as required in the question. So return BII. Given that P equals 2 and G inverse does exist, find an expression for G inverse of X, right? So G of X has been given over here, and P is said to be 2. So you do substitution right here. P equals to 2 implies that our G of X now becomes 2x squared minus 2x and then plus 6. Right, and then to find the inverse, first we let g of x equals y. So we replace g of x by y equals 2x squared minus 2x then plus 6. We interchange x and y so that we have x is equal to 2y squared minus 2y plus 6. And now we make y the subject from here. However, because y is mixed up in a quadratic equation, you have one that has a squared and then one that has exponent 1. So we don't need to go the usual way that we make a variable the subject in a linear equation. This is a quadratic, and we need to apply the completing the square method to make y the subject. Right? So I'm going to complete the square of this. I'm going to move the 6 all the way to the other side of the equation. So we have x minus 6 is equal to 2y squared minus 2y. And whenever we try completing the square, we need to make sure that the coefficient of x squared, in this case, that's y squared, right? Coefficient of y squared is 1. And At this point, it is 2. So what we can do is to factor out the 2, or better still, try and um, divide through by 2. Since this is an equation, I'm going to divide through by 2. So here by 2, this by 2, and this by 2. So that's, we have y squared minus y is equal to half of x, and then minus 6 over 2 is 3 over here. Now you can complete the square here by finding, so the coefficient of y is 1. You find half of 1, and that is half. Then we go y to coefficient of y is -1. You find half of that is -1 over 2. So we add it inside the bracket, so y plus -1 over 2 all squared, and then subtract it outside the brackets. -1 over 2 all squared is equal to half x minus 3. Right? Then the first term becomes y minus half all squared. Then we send this to the other side. We have half x minus 3. Then this becomes positive 1 over 4. Send to the other side becomes, so because of this negative, send to the other side, it becomes positive 1 over 4. Then we try solving this as well. So here we have y minus half all squared is equal to, so we solve this side over here, we have half x, and then 1 over 4 minus 3 is -11 over 4. And of course, the expression at the right hand side, we can equally write it as one fraction. Write it as 2x minus 11 over 4. So I'm going to use this expression for the rest of the work. So we take square root of both sides, and then we have y minus half all squared. Take square root of this side is equal to the square root of 2x minus 11 over 4. Then here we have y minus half is equal to square root of 2x minus 11 still remains 2x minus 11 since we do not know the value of x. Then square root of 4 is equal to 2. Next is we move this 1 over 2, or we add 1 over 2 to both sides. So that's y is equal to half root of 2x minus 11, and then plus another half. If you like, you can decide to factor out the half, but then this is also enough. So better, so you can write y is equal to half out, and then root of 2x minus 11 and plus 1 over here. And finally, you replace y by d inverse of x is equal to half any of the expressions written up there accepted plus 1, and that is d inverse, given that it existed and p is equal to 2. So that is all for May-June 2026 paper 1-2. Make sure you are subscribing to our YouTube channel and hitting the notification button so that you get notified of any new development here. If you need any assistance in whatever thing has been said over here or any other thing, do not worry to email us at sirmatsofficial@gmail.com. Wishing you all the best in your studies and in your exams as well.